I'm going to give you the information now that you're going to need for this first data collection of the Lactase Enzyme Lab. So the first thing that I want to show you, actually the first thing I want to make sure I reiterate is that this is a summative lab, so all the parts of it are going to be worth just as much as a unit test. Some of it is going to be individual, your data collection, your sharing of the data, and the 2 graphs that you make before you start all this, right? And also the HHMI Ed puzzle that I put up for you. And I want to tell you about that. There were some of you that saw the due date and you dove right in and you were wonderful and you got it done. And then I think some of you maybe didn't realize that it was summative and maybe you didn't quite get as good a grade as you wanted. So I had some anxious emails from people. And I want to apologize about that. So, you know, if you went in early and tried to get it done and then didn't feel like you did as well as you could have, I'm willing to reset those grades for you and let you try again. Okay? Because I realized that was confusing. The Ed puzzles that I make that are going to be summative are going to be 1 try. And for the rest of the year, I'm not going to do this. I'm not going to keep doing Ed puzzles. But this was confusing, I know, because I don't usually make Ed puzzles for accuracy. And all of the Ed puzzles you've been doing for me, you knew weren't supposed to be for accuracy, because I told you they weren't. But this one is. This one is actually part of the summative lab. So let me share with you what you can find in your classroom right now. In terms of, I think I'm just going to share the entire screen so I can just flip around a bit. Accordion down. Here's your 8th period Google Classroom. So I put all of your lab materials in one folder. They're all right here. So the Ed puzzle I'm talking about is right here, this one. Some of you may have gone in and tried it. You know, you turned it in already. And it's part of the summative grade for the lab. So if you feel like you didn't do as well as you wanted to on it, I'm going to reset it today once, and that's it. Unless you got 100, and then just keep your 100, okay? But I want you to take your time with that. And it does say, look in your notes if you need, but it did say that. But I still had some people who kind of freaked out because I put the due date a little too early. You do need to have the information under your belt when you write your group CER, which is going to be today. It's going to be a different day. Okay, we'll talk. So now let's go over here. There. Okay, let's look at the overview of the lab. So if you look at the Murdoch Lactase Lab overview, here's where all the parts of the lab, I wrote them all down and explained everything. Okay? So that HHMI evolution of lactase Ed puzzle is worth 10 points out of 100, and it's individual. Okay? So if you got a 90% on it, I would put a 9 here for you. If you got a 60% on it, I would put a 6 here for you. Does everyone understand that, how that works? I can't see your chats, but if you bump in some chats, some thumbs up, then I'll know that I'm not just sitting here talking to myself. My mic is on, right? Yes. I hope that I can see if that's thumbs up. The risk of yes. Yes, oh, good. You're giving me thumbs up. Thanks. Okay, let me go back to that. Okay. So that's 10 points out of 100. Okay. Then the part you're going to do today is the data collection. That's also individual. I'm going to show you exactly how to use the simulation in a minute. Okay. So you're going to either go into a breakout room collecting for pH, or you're going to go into a breakout room collecting for temperature. And you're individually going to go into the thing, and you're going to do 2 trials and enter them into a sheet for yourself so you can keep track of it. And then you're going to go to a class Google Sheet where we're going to share all our data, right? So that's individual. And then for homework, before you come back to the next class, I'm going to repost the class data. It's going to have a bunch of data that you all put in there today. And you're going to use that data, your own file, you're going to use that data to make 2 graphs, one for temperature, one for pH, based on the class data that I'm going to share with you once you all get done collecting it. Okay. So that's what's going to happen today, these parts here on day 1, right? And then your homework before day 2. And then eventually, there's going to be a day where there's a final group graph and CER slideshow creation where you're going to go into group. You're going to share each other's graphs, talk about who has the best ones, and use the information that you got from the HHMI and from me talking about enzymes and everything that you know about enzymes to do a really good CER writing and answer the questions. Very similar to how I did with the muscle that you did, okay? And that's going to be 60%, which is going to be what your group creates. The other 40% are the 2 graphs you make ahead of time. I'm not really going to grade for accuracy. I'm just going to make sure all the parts of them are there, okay? And the data that you share today, making sure the data is good that you shared, and then the 10 points for your ed puzzle that you do. Okay. Does everyone understand the parts of this? That's a yes. Okay. All right, so now let me go to let me go back to classroom for a minute. Now let's look at what's in this folder. Let's look at what else is here. All right. So here's what you're going to use today first, your period 8 lactase data entry form, okay? So if you open this, and I'm going to open this, you're going to have, it's not very long, it's very short directions, and there's one table if you're getting temperature data, you would put your data here. 2 trials only is all I'm asking for. And then if you're doing pH, you would put your data here. You're going to do one or the other. And at the top of this, there is a link for the actual, there. If you open that up, hopefully now you're on the same page as me, you see a simulation page that looks like this. Okay. Before I go any further, I'm going to talk to you for a minute on the whiteboard and make some drawings because I think there's some things that need to be explained first. Okay. So now, this is what a lot of you, some of you may already know how to do this, but some of you may not. And I want to make sure that I tell everybody before I ask for it. Here's the skill that you need in order to get this data today. You need to be able to, how do I get rate values from a graph that shows something changing over time? That is the skill I'm about to show you how to do, right? How do I get a rate value from a graph that's showing something changing over time? So here, let me draw it for you. Let's say that we have a graph. I'm going to show you exactly what the simulation is going to show you. My 2 axes, do my line straight. Okay. And over here we have concentration of the product, which in this case is going to be glucose. And down here we have time in minutes. It's time in minutes. And the curve that you're going to get every time you're measuring enzyme activity, especially if you have a test tube or beaker where it's happening and the amount of substrate you're adding is finite, right? There's only so much substrate in there, so it's going to run out and all turn into product over time. You're going to get a curve every time that looks like this. It's going to look like that. Every single curve that you do when you do the simulation is going to look like this. Okay, so here's what's going on. Anytime you have a curve like this, where something is changing over time, what you can do if you've taken your math classes and you've seen this maybe in chemistry and physics, I don't know, but you can determine, like at any point along here, you could determine how fast the reaction is going here, and then how fast it's going here, and then how fast it's going here. Exactly, yes, Julia, that is what you are way ahead of me. Yes, okay. So calculating the slope of the line at any point is going to give me the speed of reaction at that point. There's the sentence. There's the key sentence. So the slope of the line at any place along here is going to give me the rate or the speed of the reaction at that point. Okay, so let's type that. Rate equals slope, which equals change in concentration of glucose divided by change in time. So let me ask you this. Where would the speed of reaction be faster? Here or here? Where is it faster? Yeah, it is. Yes, Krishna, you can think of it like a derivative. You could, yes, actually. You're taking the derivative of a line and changing it to a rate. Yeah. You don't need to think about it that way, though, for this. You can just think of it as getting the rate at a particular point in the line. So as I go from left to right, let me ask you this. Is the rate getting faster or slower as I go from left to right? Tell me that. Yes, you've got it. Yes, very good. So as the slope of the line gets flatter and flatter and flatter, the rate of the enzyme activity is getting less and less, slower and slower until it's barely working. Now, why do you think that's happening? Why do you think all of a sudden it's to zero here? It's not working at all. Remember, we're in a test tube, right? What's happening in there? It's slowing it down. Exactly, that's it, Erin. Okay, so over time, since you only have so many lactose molecules in here to begin with, they all turn into glucose, right? Okay, so you put in here, you put two things, and this is true in the simulation. You're putting a certain amount of lactose, which is the substrate, that's the sugar, and then you're also adding lactase, which is the enzyme that breaks down lactose. Thank you very much. Okay, so what's happening? What's the enzyme? What's the actual catalyzed reaction? Lactose, right, is a disaccharide sugar, and it is turning into its monosaccharides, glucose and galactose. There, that's the reaction that's being catalyzed here. They are measuring the accumulation of this, right? Right, that's why this is over here. So there is lactose in there to begin with, and over time, that lactose turns into glucose and galactose. They're only measuring the amount of glucose. But an indicator, yes, exactly, right. So it works faster in the beginning because there's lots of lactose in the beginning. But then as the lactose disappears and turns into glucose, there's no more substrate for the enzyme, so that's why it slows down. Okay, so that's good. That's all well and good. You guys are not going to be testing substrate concentration. You're only going to be testing temperature and pH. So let me get you to that before we run out of time. We have until 12:25 today. That's going to give you plenty of time to get your data. So let me how this works. Okay, Erin, we're going to talk about that. I have a feeling that we may have to move where we put this this final group project, okay? But I haven't made the final decision yet. Not in the test tube environment unless you were to add another. Yes, we've been in 6 periods since 11 something, 11:10. Well, I can't remember. Yes, we've been here for a while. Okay, so here is your environment where you're going to be gathering your data. So let me show you this. If we're just to run the experiment, here's your test tube, right? And it starts with lactose in it, and it's blue when there's lactose in there. And then if I press run down here, I leave all the conditions alone, I don't touch anything, look what happens. The blue turns to orange, which is now glucose, right? Everything's turned to glucose and the reaction is over. And you have a curve that looks a lot like the one I just showed you, right? To get the rate, slope of this curve, I
don't think we can see it. Yeah.
Oh, I'm sorry. Okay, hold on. Let me fix that. I thought I was on share screen. I'm not. Thank you for telling me. Hold on. Let me get that. Let me just share the entire screen there. Down, go down. Okay, can you see it now? Yes? Sorry about that. Okay. All right, so this is your simulation screen. This is where you're going to collect your data in a few minutes. I'm going to let you go do this. So the blue is lactose. When I press run, look what happens. it turns into glucose. Orange turns into glucose. And you get this graph that looks a lot like the graph I just showed you. Now, calculating slope, guess what? It's a lot simpler than dealing with rise over run and all that. It's actually really easy. Here's what you do. Look at my little x. I'm going to bring it down to where it's at 10 minutes. See that? You're going to be calculating the slope. Well, you don't even have to calculate. All you have to do is get the rate of the reaction from 0 to 10 minutes. And all you have to do for that is look down where it says beneath that glucose. You see where it says 21? You see where it says 21 down there? Look here, right, when I put it on the 10. See that? And all you have to do is divide 21, thank you, but divide 21 by 10. So really, you're just moving the decimal over. That's it. So this first rate, if you were taking this data point, 2.1. That's it. Now you reset it, and you can do another one. If you are doing the temperature collection, if that's the breakout room you wind up in, you're going to do temperatures at 0 and 10 and 20 and 30. You're going to go all the way up to, I think, 60. Okay? And you do them twice each because you're going to do 2 trials each. So, for example, I would do my first 0 trial by setting it at 0 and running it. And what this means is your answer is 0, okay? There's no activity at 0 degrees. So you can probably not even reset it and be pretty sure that your 2 0-degree temperatures are going to be the same. There, 0 and 0, there's your first 2 data entries. Reset, go to 10 degrees. You know, you keep everything else in the simulation alone. You're not going to change anything else. All the rest of these are constants. Temperature is your IV. Now you're going to collect at 10. So run. Go to 10. It says 14.7, so my rate would be 1.47. Okay? Reset. Go to 10 again. Run. Go to my 10-minute mark. 17.4, so my rate is 1.74. Write it down. Reset. Now I'm going to go to 20 because that's my next temperature. 20. Run. Go to the 10-minute mark. 27.4, so my rate is 2.74. Reset. Go to 20 again. Run. My second measurement, there's a lot of variability in this, is 36.3. So I would write 3.6301. Now, what if you're in the pH room and you want to vary the pH? pH varies from, I think, 1, 3, 5, 7. If you look at your your data input, there's a table there ready for you to put the numbers in. So your first measurement would be at pH 1, and then everything else would be the same. So I go to pH 1, and I run. I go to 10 minutes, and it's 0.658. So, okay, so my rate, move it to the left, would be 0.066 would be my rate there. Okay. Reset. Go back to pH of 1 for my second trial. Run. And then it's 0.74 glucose, so my rate would be 0.074. Okay, how are you doing with this? Did everyone understand what I was doing there? Are there any burning questions about that? You got it? Okay, I'm going to come around and help just in case, but I'm going to put you in 2 giant rooms. You're either going to be in the pH room or the temperature room. And your job is to collect those 2 trials. Remember, they look like this. Let me show you what they are. Your data collection sheet looks like that, right? That's what it looks like. It's in your classroom. You're going to go there, and you each have a copy. You're going to either go to the temperature table and follow those directions, or to the pH table and follow those directions, okay? And then also, please realize that people got confused about this. Let me just make sure that's your data entry place to put your data. But I also want to show you the class Google Sheet. which I'm going to leave up so that I know when you're getting those in. Okay. Yes, Indira, yes.
How did you differentiate trial 1 and trial 2 again?
I just reset it.
Okay. Cool.
Do you want me to show you that again? All I did was reset it. You push the reset button and then put it back to the temperature you needed to do the second time and then run it another time. That's how you do it.
That makes sense.
Okay. There is a Google class sheet that I have to up here. But the Google class sheet has a tab at the bottom. One for temperature, one for pH. Make sure you're putting your data in the right place when it comes to the class sheet. Okay? Okay, I'm going to go ahead and put you in here to get started because otherwise I don't want you to run out of time. So we're going to just have, we're just going to have two groups, two giant groups. And wherever you pop in, look at the name of the group and that will tell you which IV you're doing. So some of you are in the pH room and some of you are in the temperature room. And I'm going to come around and make sure you're doing okay. And if you have questions, okay? So you want to get into your data entry sheet and open up your simulation and then just let me know if you have any issues. Okay, go. Hmm.